called a chain inequality. It also is an and inequality. And what we mean by an and inequality means that we're going to be looking at the intersection of two graphs. So the first graph we're going to look at, or the first inequality we're going to look at, is this one on the left. And notice how I boxed it in so that I have the middle expression with the left-hand expression. So I'm going to have negative 1.25 is less than or equal to 2x plus 3 over 4. And then I'm going to write another inequality, and the other inequality is again going to include that middle expression with the right-hand inequality. So I'm going to have 2x plus 3 over 4 is less than or equal to 0.75. And then I want to make sure that I put the word and in between, so I remind myself later on that that's what I'm going to be looking for. Now to solve this equation, this inequality, I need to get rid of my fraction. I don't like the 4 being on the bottom here. So to get rid of the 4, I'm going to multiply by my LCD, which also happens to be 4. So I'm going to take both sides of the inequality, multiply it by 4, and when I do this, the 4 on the right side cancels out with the 4 that I'm multiplying by. So the only thing that I'm left over with is just what I have up in the numerator. So then simplifying this, on the right side I end up with 2x plus 3. On the left side I need to multiply 4 times negative 1.25. And when I do that I end up with negative 5. I'm going to do the same thing over here. I'm going to multiply both sides by 4 to get rid of that denominator, and my 4's on the left now are going to cancel out, and I'm left over with 2x plus 3 is less than or equal to 3. Now I have a basic inequality to solve. I'm going to subtract 3 from both sides. I end up with negative 8 is less than or equal to 2x, and then I'm going to divide both sides by 2. I don't need to worry about switching the inequality because I'm dividing by a positive number, and I end up with negative 4 is less than or equal to, over here with the other inequality, I'm going to subtract 3 from both sides, and when I do that I end up with 2x is less than or equal to 0, and then I'm going to divide both sides by 2, and 0 divided by 2 is 0. Then what I'm going to do is I'm going to make myself a number line with my answers on it. So here's my number line, here's 0, here's negative 4, and my first answer is this one over here, and it's kind of hard to read, and so it might be helpful for you to rewrite this as x, and which way is the mouth? Is the mouth on the x or is the point on the x? Well, the mouth is. So the mouth of the inequality, so I haven't changed the inequality, it's still with the x the same way. Now it's a little bit easier to see that I'm going to have x is going to be greater than or equal to negative 4. So greater than or equal to. So that would be the greater than part. And then the second inequality that I'm looking at is x is less than or equal to 0. So that's going to be over this direction. And since it's an and inequality, we're looking for the intersection. And the intersection of these two graphs is between negative 4 and 0. So then writing this in interval notation, my answer is going to be negative 4 to 0. The second problem I'm going to do is problem number 68 in section 6.2. And that is 7y minus 5 is less than or equal to negative 2, or 7y minus 5 is greater than or equal to positive 2. This is an or inequality. Or inequalities mean we're going to be bringing the two sets together. So it has to be in one set. So answer must be in one interval or the other or both. So that's where the ors come into play. It must be in one interval or the other interval or both intervals. So I'm going to go ahead and solve these two inequalities. I'm going to add 5 to both sides here, and I end up with 7y is less than or equal to 3. Then I'm going to divide by 7. Y is less than or equal to 3/7. Then I'm going to solve this one the same way. I'm going to add 5 to both sides. I end up with 7y is greater than or equal to 7. I'm going to divide by 7. Y is going to be greater than or equal to 1. Now I'm going to go ahead and draw myself a number line, and notice that I have 3/7 and 1. So what I'm going to do is I'm going to divide my graph and make each hash mark worth 7. So this is going to be 1, 2, 3, 4, 5, 6, 7/7, and 7/7 is the same as 1. So this is 7/7. So that makes my graph a little bit easier to do. If I'm going to be graphing y is less than or equal to 3/7, so 1, 2, 3/7 is right here. So that is y less than or equal to 3/7, or y is greater than or equal to 1. And this is a typical OR graph. It's not 100% always this way, but this is a very typical one. And then I need to write my interval notation using this graph. And to do that, I end up with reading left to right. This interval starts at -infinity and it comes up to +3/7. Or, and the symbol that we use for OR is that union symbol. Oops, and I forgot to make this inclusive. Inclusive 1 to infinity.